Hello, good morning. This is Naz from NB Network Lessons. Hope everyone's doing okay and in a fantastic mood. Thank you so much for joining. My today's topic is discussion of finding x and y variables in a function. When a function has two variables, x and y, how do we apply chain rule to find the derivative of individual function only with x and then only with y. So in my last lecture, I discussed the quotient rule, and my today's discussion is going to be around chain rule. So ideally, what I'm talking about is that when you have function which has x also and which has y also, how do you find derivative of that? Okay, how do you find derivative of that? Because in reality, in two dimension, when you have x, you have y, and even in three dimension, when you have z, and you have been asked to find a function at a certain point. So how do you do that? So the way you do it, the way you approach is that you find function. For example, let's say we have a function. Let's say I have x, y, z equal to x square plus y square plus 3z. Okay. So the way you find derivative is that, let's say you have to find it just for x. So this is the way you represent f, and then subscript x. You treat y and z constant, and you just take the derivative of x. So in this case, the answer would be just 2x. Okay. So then if you want to find the derivative with respect to y, then what you have to do is say f and then y subscript, and then you keep x constant, you keep 3z constant, and as you already know, derivative of a constant is 0. So then we just get 2y. And then what we have to do is lastly find the derivative from respect of z. So we keep x and y variable constant. So then f subscript of z would be equal to just 3. The derivative of 3z is just 3. So now, since I gave you a refresher, now let's go ahead and take a look at and see if we can solve a problem using chain rule. Okay. All right, let's go ahead and do that. Let's say we have something like f x two-dimensional. We are finding x and y is equal to 4 minus x square minus 9y square, and the whole thing is raised to power of half. Now, how do you guys remember chain rule? When I showed you, chain rule is basically you take the derivative of the big picture, the larger picture, and then you take the derivative of what's inside the picture, the smaller picture. So let's go ahead and say we take the derivative with respect to x. Okay. So then what I have is half into, I'm taking the derivative of the big picture, 4 minus x square minus 9y square, and then half minus 1 is negative half. And I'm applying the chain rule multiplied by what's inside. Now inside, we're taking derivative with respect to x only. This is treated as constant. This is already a constant. So then it's going to be negative 2x. All right. So this is the function of x and y with function of x with respect to x. Now let's go ahead and see if we can take the function of y. So function of y is going to be equal to, you take the derivative of the whole thing, just like we did last time, half 4 minus x square minus 9y square, and then we have negative half into, we're applying the chain rule. Now we're taking derivative with respect to y. So this is already constant. We treat this as constant. So then it's going to be minus 18 y. Okay, so essentially you can simplify these two, but that is your answer. So basically, in what you're doing is that you're finding function with respect to x and function with respect to y when you have a function which has two variables. If there was another variable z, three dimension, we would have solved for from perspective of z. By the way, if I ask you, let's say if there was a z right here, just imagine, okay, and I asked you to find function with respect to z, take the derivative of that using chain rule, what would you do? Well, there is no z in here, right? So then it would be just zero, because we treat a whole thing as a constant and derivative of constant is zero. So that's all I wanted to talk about today. You all have a good day. If you like the contents, please go ahead and share and give me a like. Thank you.